Hello, everybody. Well, I don't have to do anything anymore because Blanco already told everything. Thanks for the nice introduction. So today I want to talk about Python and Blender, both the pleasure and the struggle. Don't worry, it's about like 2/3 is pleasure and then 1/3 is struggle. Hopefully I can afterwards talk with some of you folks about that struggle part, because it would be great to have some help in that. So I'm with Blender, audio works, that's great. So first I want to just show you a demo reel. It's like the Blender 4.0 feature reel, so that you can see a little bit of what people do with Blender, what kind of different styles you can create with it. So that's a little bit of Blender. As said, it is an open source project. It's quite old already, not as old as Python. Like Python started in 91. Blender actually started in 94. Don Roosendaal, still my boss, he still runs the company. He started developing it in 94. It wasn't even open source back then, but it was already freely available, at least on free operating systems. If you were running Windows, then you had to pay a little bit for an activation key. 2003, it did become open source, and I have like a list of all the splash screens of all the different versions over the years. It's kind of funny to see. And it also like shows how old the thing is. Also, look at the years over there. We'll come back to how I animated that later. Maybe you saw some of the open movies that we've been making over the years. Blender 4.1 is the latest release. So as with any other open source project, it is all about the people. And I think for Blender, that's a very strong component of what makes Blender such a special project. And because Blender is so widely used, really from like Hollywood VFX studios to people at home and children at school, people tend to think that it's like run by a huge number of people. And it's not really. It's like sometimes it feels very small, sometimes it feels very big. So I just wanted to show you the people that are currently actively being paid by Blender to work on it. So we have 33 people at Blender HQ, which is actually in Amsterdam in the Netherlands. And that is development, organization, but also an in-house animation studio. And then we have 18 more people who are working remotely from like the US to China and the stuff in between. So there's in total 51 people on payroll, and the project has never been bigger than this. I think it's fantastic. And of course, there are many, many more volunteers. So I want to show you a list of all the names of people. It's in 2 columns, but because the text got too small, I had to cut it up and like put it in, like rewrap it a little bit. The left-hand column is all the people that worked on Blender 4.1, latest release. The left-hand column is everybody who has at least one commit in. So after I often explain to people like what is open source, and we make this stuff, we give it away for free, and we have this animation studio. Oh, do you work for customers? No, we don't. We just do the stuff that we like. So then immediately, always, next question, how do you make money? By the way, I'm going over this quite rapidly because we only have 45 minutes, and then it's time for your beer. I know I'm in the way of that. So we have donations to the development fund, and that is going into the Blender Foundation. That is an actual foundation that protects the Blender copyright. It also can protect developers. Like if some other company starts to claim that we stole their techniques or whatnot, Blender Foundation is there to protect our developers. And basically, the foundation is there to make the Blender work possible. Then we have Blender Institute, which is the company that actually does the Blender work. And that also receives subsidies, regional, European ones. And then finally, we have Blender Studio, the animation studio. They also have a website where you can get a subscription. And through that subscription, you support the animation studio, and you also get a lot of practical knowledge. There's training videos there. There's all kinds of techniques that the studio has developed with Blender. You have all kinds of stuff that you can download, characters, models, etc. So this is the Blender Fund website. You can see how much we get on that. Looks like quite a bit of money, but if you divide that by 51 people, it's like, yeah, OK. Here you can get a membership, then you pay per year or per month, or you can just do one-time donations. There's corporate memberships as well. This is always funny when a new corporation pops up, especially when it's like Meta or Adobe. It's like, oh, Blender is being taken over. It's like, they sponsor us, that's fantastic, but they don't have a direct say in what happens unless it aligns with what is good for all Blender users. And then there's also individual memberships from all kinds of studios, smaller, like independent studios. They can exist because Blender is free, and therefore they give some money to the Blender Foundation in order to ensure that development continues. And this is the Blender Studio website where you can find all that stuff that I just talked about. So that's about Blender. A little bit about me. Why am I here? What's my history? Well, I come from this country. We have tulips. It's usually a little bit flatter than this. It's more like this. I come from the northern part of North Holland. Worked on a bunch of different videos. These are a few of the film posters of that. And in '97, I drew my first breath. In '91, I was 12. I wrote my first bit of software on a Commodore 64. Found that absolutely magical. Then in 2003, I started using Blender when it became open source. And shortly after, I started working with Python while I was doing my computer science bachelor. One of the assignments was to create an RSA implementation. It's like encryption, uses big numbers. Python can handle these big numbers very easily, so I wrote a little library for that. That was very scary because I made it cooperate with other encryption standards. And then it became popular because of reasons. And then for years, it was in the top 20 most downloaded Python packages on PyPy. And then I made a mistake, and then the Google Cloud command line client started to break. It was so fast forward a little bit. I was doing my PhD with Arjen here. On crowd simulation. I wanted to run that simulation in the Blender game engine. Game engine couldn't do what I wanted, so I started sending in these patches to extend it, and that is how I got commit access to Blender. And a few years later, I actually managed to land a job there. First as a web developer, did a lot of back-end, worked a lot with Python. So also I made a training series, Scripting for Artists, that goes over how to do stuff with Python for people who don't want to become a Python developer, for artists who just want to get rid of their repetitive work. In 2018, I became animation and rigging module owner, so that's when I moved more towards actual Blender development, which was my point all along. And that is still my role. I lead the development of all the animation tooling. So before we start looking at how to script stuff, what does Blender look like? Let's go to, if we can lower the volume a little bit, perfect. This is the credits for one of our recent shorts. And on the right, you see Blender, how it was used during the production of the short. So you got the armatures, you can move stuff around. We have a post library, and like you can see in the 3D viewport on the left, sorry, it just renders it pretty much real time. And you can also do video editing in Blender itself. So this is the actual edit of that short. So let's look at the Python side of things, because that's what you're here for, of course. So when you want to use Python in Blender, first thing you do is you go to the preferences, you enable developer extras, you enable the Python tooltips. And then once you've done that, you start hovering over like a location property of an object, for example. And there you can see is normally it would show just location of the object. But with these guys enabled, you can see it is like Python is object.location. I don't know, is that readable enough for back there? It says object.location with a capital O. It's a different object than the Python object. It's the Blender object. And it has bpy.data.objects cube .location 1. We'll see that later also. So already you hover over a property, you can see how you can access it in Python. Another thing is that Python is our GUI glue. And you can right-click on a bit of UI, click at the bottom on Edit Source, and if you happen to have an editor open, like Blender also comes with a text editor, it will actually open the file for you and put your cursor on the line that draws that property that you just said view source to. So if you want to figure out how to like copy-paste from the Blender code to create your own UI, that's how you can do it. Apart from that, we also have operators. And these are defined either in Python or in C++. Like Blender itself is made in C originally. We're transitioning to C++. That's almost done. And these operators are bits of code that sit between like menu items, buttons, hotkeys, those kind of interactive elements, and actual code that needs to run to make the thing happen. Also, this interacts with like the undo system so that a new undo step is saved, so you can actually undo what you just did. And there is some more Python in there. We'll get to that later. So first, let's look at how you do something in Blender in the way that everybody, well, every developer likes, just copy-paste stuff. So the cool thing is that all those menu items are, we start first by again, right-click on that location property and copy full data path. When you click on that, and then you go to the Python console that's also built into Blender, you can press Ctrl-V, and then it pastes the code for you. So there you get bpy.data.objects cube location 2, because I just right-click on the Z property. You can use array notation, you can use .z, you can manipulate it. And as soon as you say, well, plus equals 1, you can see that it just lifts by a meter. It's like immediately updates your viewport. Also, you can just assign, like .location is a vector, you can assign a tuple of floats, and it will just automatically convert that into Blender's vector type. For these operators, same kind of thing. You press Shift-A, or you drag your mouse to the Add menu, you go to Mesh, IcoCube. When you click on it, you would get that object, but when you hover over it, you can press Ctrl-C, and then you can go to your Python code, press Ctrl-V, and then you have the Python code that would have run the same thing. And then you can remove the closing parentheses and press Tab, and then you get auto-completion, and you can see that there's all kinds of different parameters that you can give. So that's a super easy way. If you need to create a lot of objects, you can just put this into your Python script. If you want to find more information, you can use the Blender user interface, as we said, but also in Blender you can go to Help, Python API reference, or developer documentation, and you're just brought to our documentation. Now, before we look at more how to do stuff with Python, there's the DNA and the RNA. I want to talk a little bit about how Blender deals with its data model. And this is also a bit of a dive into history. So DNA is Blender's main data model. And that is designed over there. If you have very good eyes, you can see that part of this is in Dutch. And this is what Ton actually thought up, like 94-ish. You have the main structure here, and it is just a flat list of things. Objects, meshes, screens, like windows, the layout of the user interface, armatures, all of those are stored in flat lists per type of thing. These are identified by name, and that is then stored in the blend file. Blend file is just a memory dump of whatever is in those lists, and that's pretty much it. Except that it also includes the structure of those structures itself. It has as a metadata which fields were in which structs. And so we have versioning code in there that can say, oh, if that field isn't there yet, that means it's too old, and then I need to initialize it to that, or I need to do whatever. And there's a whole list of these functions. If it's older than this, do that. And that is why you can still open pretty much a Blender 1.0 file from that era into current Blender, because this structure pretty much hasn't changed in about 30 years, which I think is fairly impressive. Then we look at RNA. I want to apologize to anybody who has a bit of biology knowledge. The DNA is really the core data structure of Blender. So calling that DNA is kind of okay. DNA also stores information. This is the information in Blender that kind of matches. This is more like, yeah, this is a related thing that we give a related name. It's a wrapper around the DNA structures and substructures. And that wrapper defines RNA properties. So that dot location that we've seen is a RNA property of type vector of length 3. And that can give you types and methods to call on it and all kinds of stuff. And this is used in the user interface. So when you want to make a user interface in Blender, what you need to do is first think about the data that you're modeling, create those properties for it. So you don't think about like adding a checkbox somewhere. You have to have a Boolean property, which you draw on the user interface, and Blender then knows it needs to be a checkbox. Again, also for like a float of 3 numbers, you can give it a subtype, and then you can tell it whether it's a distance, and then it shows it in meters, or in like Imperial Stormtrooper units. But if you say this is a color, it will actually give you a color picker. And so it's really data-driven user interface design, which has its challenges, but also it's a lot of benefits. The animation system also uses this. So these paths, like .location.z, is also what is stored in an animation curve, and that is how Blender knows what it needs to animate. And also, of course, it's the Python axis. So you have the RNA path, which, for example, pose.bones and something in the bones, and then the location of that with an array index, and that is how a lot of tools like access the information in Blender. And we have the bpy.data.something, and that something are these little lists in that main structure that you saw earlier. So more users of Python. Drivers are a big thing. These are also part of the animation system, but then are little expressions. And this is the driver editor. You can see it, or you can hardly read because it's a bit fuzzy, sorry about that. You can add several input variables. This object is the splash screen's image that is scrolling down over the screen. And that defines variable y. The expression is currently y. And that has a certain value. And then this is a mapping from horizontal, the value of this expression, vertical, the eventual value of the driver. And that is what I used as the y-coordinate of that little spotlight that goes over the years. And so when I move that big image of all those splash screens up and down, that spotlight automatically picks the right year for me. That's what you can use drivers for. This expression is actually, if it's simple enough, we use something that doesn't use a global interpreter lock and is a bit faster. If it gets more complex, you can just use Python code there. You can also register functions that you then can call from the driver editor. Then let's look at the main thing that people use Python for, that's add-ons. I have a QR code there. I hope it scans with the fuzziness. Because I'm not going over the entire script, I'm just highlighting a few bits. It's going to stay on screen for this whole section. So we're going to look at writing a function in Python in Blender, calling that from an operator, skipping a bunch of things, adding the operator to the menu, and then enabling the thing. So this is an example function. Let's create a monkey grid. We loop over stuff. I think you understand Python. Here is a monkey grid. You'll see what a monkey grid is. Like, we have, of course, like a Shift-A mesh, and then you have a bunch of primitives, like a cube and a sphere and a different kind of sphere and the cylinder and like the basic shapes. We don't have a teapot. Blender has Suzanne, which is a little monkey head. And so there is a bpy.ops, an operator .mesh.primitive monkey add. This function will call that operator for us with the right location. Here you see the text editor in Blender with the name of the text data block. And then on this side, bpy.data.text with that name .as module. And that function will actually interpret this as Python code as a module, return it, and you have a reference to whatever Python you wrote there. And so on that, we can just call that monkey grid function. Another way to integrate your Python code with Blender. And this will create, as you can see, a grid of monkey heads. No, not yet pain. So now let's look at how to make an operator. Operator is a class. Its subclass is bpy.types of the operator. It's fairly straightforward once you know how it works. It has a name, a description, and an execute function. And that execute function needs to do the stuff, and it then returns either completely canceled or finished, depending on whether it could do its work. And this is then registered. No, not yet. You can put it somewhere in the menu, bpy.types. Some menu type, like the operator had in the struct name, in the class name, OT for operator type. Menus have MT, panels have PT. And so you can, in bpy.types, you can find all these different types for all the menus and the panels, and you can just call .append, and you get a function. You can register a function. That function can say, look, layout, draw the operator, and that adds it to a menu, to a panel, and that is how you can extend pretty much anything that you see in Blender's user interface and add your own stuff to it. With some magic of skipping a few slides, we have an actual add-on that you can enable, and that will call that register function, and there you have your add-on. If you're interested in downloading, did the little guy, did that scan properly for people? Yes? Good. I would say have fun with this. Python whole standard library is available within Blender. We also do our best to not diverge too much from standard Python configuration, compiling options, that kind of thing. Because then tutorials about Python that you can find online should also just work with the Python that is built into Blender itself. Requests is a module that is available for you. NumPy is also bundled with Blender. And so that gives you already a lot of ingredients to start working. Blender also provides a GPU module. And with that, you can register your own shaders, and you can do all kinds of stuff, like in the 3D viewport even. So there is add-ons that draw all kinds of extra helper lines and onto the model that can help with retopology, if that means anything to you. But they add all kinds of tooling. They even built their own user interface with an HTML library that can then render to OpenGL, and that presents itself in the 3D viewport. So there's a lot of stuff that you can do. And that is now yeah, really time to look at the pain. So this was a lot of fun with Blender. And as I said, there's already a bunch of libraries that are shipped, like requests and NumPy. But those are not the only things that people want to use. Maybe you want to have some library for like a language model to connect to OpenAI. So managing dependencies of your add-ons becomes a bit of a struggle. And the big problem is getting those dependencies and isolating those dependencies. And to illustrate that, I want to talk a little bit about the Blender Asset Tracer. And I really love like the unique code for the little bat. I think it's really cute. Blender Asset Tracer is a tool that was written to parse a blend file. It's used by our render farm software, and that will look at the blend file and see what's in there. It understands the DNA structure, how to parse that, and it can follow all the pointers and follow the other blend files and images and textures and other files that it needs to render that one input file. And so it traces all the assets that are used, that are necessary to render that one file, so that it knows what to send to the render farm and what not. So BAT is a library. You can just do pip install Blender Asset Tracer with dashes in between, and you download it. And we had an add-on for our render farm. Worked fine. I needed something extra. I had a function to BAT. I call that function from the add-on, bundle it together, ship it, send it, done. And then I got a bug report saying that function doesn't exist. And their add-on crashed because of it. Turns out that they also had another add-on for another reason, also bundling BAT. And of course, that was an older version because like I just released this new one. And Blender was finding the older one first, and when you do import Blender Asset Tracer, it found it on system.modules, and so it would just not load the new stuff that I wrote. So that was a bit annoying. So now in the new add-on, we have a workaround. We back up system.modules, we back up system.path, we add the location of our wheel files to system.path, load in what's necessary, and then just destroy everything we did and restore those backups. And this means that after that, nobody can ever find what we just imported because like my add-on holds the only references to it. And this works, but it has downsides. Like you can't do, like that dependency that you pulled in and that you imported can't import itself anymore. So if it does any late imports, like you're screwed, and you get a really, really nasty error message from code that was found in that wheel file that is trying to find other code in that wheel file. It's there. It found it. Why doesn't it find it again? Like, because I wrote that logic, I knew what was going on and I knew how to solve this. But this is not something you can give to a general like Blender user and tell them like, okay, this is what you can use. Like many of those add-ons are actually made by Blender artists who just want to streamline their work and want to remove the repetition or want to create something cool for their friends. And many of them just ask ChatGPT, hey, I want to write a Blender add-on for this purpose, it has to do that, and ChatGPT will do its best to make something that almost works. And then with a lot of struggle, they make it work. And that is fine, but those people will not be able to understand how to do this whole dance with the dependencies. So you get really hard to debug errors. Also, I didn't test this with compiled binaries. Like when you start loading a library like a DLL or a .so, and like, I don't know. So there's one downside. This is why this approach is used in that add-on alone and not used in Blender as a whole. Then also there's pip. Pip is great. It's bundled with Python. We also include it in the Python that we bundle with Blender. So from your add-on, you can call into pip and actually install stuff that gets installed into a centralized directory. The downside of pip is that it's very console-based. It is made to be run by a developer who understands Python and runs it from a terminal. And it's not quite possible to integrate that properly into a GUI application like Blender. And also, the whole user experience is for developers. So for something, you need to have a C compiler on your machine. Well, developer might have it, but generally, a 3D artist will not have that. And so, yeah, it works, but it's tricky, and we don't really want to rely on this at install time of an add-on. The good news, though, is that Blender 4.2 will have actual wheel support. We're moving to a new platform for extensions. We'll go to that a little bit later as well. For now, just think as extensions as the same thing as add-ons with little nice thing around it. But these extensions can bundle wheel files, and they will get installed by Blender into a directory that's specific for that extension. So at least the delivery of those files to the user is kind of solved with that. But still, we have this problem of isolation, where two add-ons can have different versions of the same library. And like, it's kind of like there are options to solve this, but like the problem I feel is that Python doesn't really support this use case very well, because we have not different applications with different requirements. We have basically one GUI application that is the host for different add-ons, which are also kind of applications. So things that we've been looking into are custom import hooks that checks whether like something is being called from, like imported from a specific library, and then make sure that the dependencies of that library are available. I think that might work for the initial import. I'm not sure how that's going to work for like late imports by that dependency, but maybe we can like make it work because that dependency is already in an add-on specific directory somewhere. Maybe something with sub-interpreters. I don't know much more about this than this word. I know that it's coming, or it's maybe already there. For now, what we have is just a list of specific package versions. And this is inspired by the VFX reference platform. That is basically a list of this version of Python, this version of Qt, this version of GCC if you want to use it, this version of Clang if you want to use it. That is used across the VFX industry, and Blender tries to follow that. And that is also why we're on Python 3.11 instead of 3.12, because of sticking with that. And for that, we can say, well, PIL is used often for image processing. You have to just use version this if you want to bundle it. But also, I feel that makes it kind of tricky, because then how do you support multiple Blender versions with one version of the add-on? So if you know more about this, when we have a beer, look me up, because I really want to talk about it. So back to these extensions. The extension platform, like one of the shortcomings of Blender add-ons was that it was just a zip file. So you download the zip from somewhere, you install it in Blender, it's an add-on on your machine. If you want to update it, you have to remember where you got it, and then go there again and download the zip again, and then install it again. And that was a bit old-fashioned. So many of those add-ons already came with their own little update manager, where you have all these add-ons that try to update themselves in different ways, and that wasn't so nice. So with the Blender extensions platform, you can actually publish your extensions on extensions.blender.org. Extensions for now are just add-ons, but later they're also going to be themes and something else. Different types of extensions are coming, but for now they're add-ons. The thing is that this makes it more like easier to just download some add-ons and have them installed and updated automatically. Also, it means that it's slightly less technical people who are using these add-ons. And so we kind of have to protect them a little bit better. Also, it's easier to upgrade, so we have more varying versions of these add-ons in different combinations with Blender, whereas earlier we just bundled a whole bunch of add-ons with Blender itself, and then when those were updated, well, that means that you got a new version of Blender with the updated add-ons. With these extension platforms, that's more decoupled, so we have also more versions to support. And the biggest thing here is we don't want these add-ons to have a network connection at all behind your back. So now already we have a rule that network connections are basically not allowed by add-ons, except for when you click on a button that says download, or when you click, you can know that you've performed an action that triggered something on the network. That's fine. but not going behind your back. This is also why Blender doesn't have any telemetry. Like, you install it on your machine, it's your thing, it's private. So what we want to have for these extensions, what would be really nice, is no network until approved, that where you say this extension can go online, so per add-ons. And I don't think we can enforce this in a way that you can't go around, because it's just running locally on somebody's machine. But I think we can get somewhere, at least, by limiting what Python can do somehow. I have no idea. If you have any ideas about this, please look me up, because I also really want to talk about this. And with that, my mouth is getting dry. I'm at the end of my presentation. Thank you very much.
This one on?
Hello.
It's on. I'll start with a question. Could you provide some examples of what people building using Python in Blender? You show some snippets, but I guess there's a community that builds stuff with Python. What are they doing?
So the add-on that I showed, the monkey grid, is not the most useful.
It's a toy example.
Now, every year we have the Blender conference in Amsterdam, and that is absolutely an amazing showcase of everything people do. So it goes from architecture to like a medical use of Blender. One of the most mind-blowing examples for me was that there is surgeons who actually have to cut up a bone after it's been broken and grew back, but slightly incorrectly. So people in their legs or their arms, there's a slight bend that shouldn't be there that is causing them problems. And so the procedure is to cut the bone at a certain point, put a little wedge in there that straightens out that bone. That then grows, like, it's a special material that grows into the bone, and then after like being supported by stuff, those supports can be taken away again, and then you have a straight leg. And what this surgeon did is doing a 3D scan of that bone, loading that up into Blender, making that cut virtually, trying out different angles, different places to cut, because you can cut and undo. That's really easy in Blender, not so much when... And so he could figure out the optimal place to make that cut. But also he could figure out the size of the wedge, the shape of the wedge, and also make a 3D model for the supports that go around the bone so that they know exactly where to drill the holes to put the metal plates in place. And with that, all of a sudden these procedures are shorter, safer for the patient, they recuperate faster. And that's one example of like how people create these add-ons for Blender that help them in their daily life. A bit more simple example was a company that makes pizzas. And they just, they designed their new type of pizza in Blender, and they can put ingredients on there, and then click the bake button. And it melts all the cheese, and it shows you the pizza.
But it's Python involved there.
That was Python, yeah. And that was like not in the game engine to make an interactive thing. That was actually using Blender itself as the interactive application to do this.
That'll be the first pizza with Python, I guess. But any questions from the audience? Anybody raise their hand? Yeah, I'll start first, then I'll go.
So how do you keep track at Blender of all the different new features of new versions of Python, and how do you benefit from those, apart from just bumping up the version?
Ooh, that's a good question. Hardly. So Blender has always been pretty much on the forefront of Python releases. So Python, I don't know exactly which 3.x version it was, but Blender was pretty early in adopting Python 3 already. I think it was around 2018 when we went from Blender 2.79 to Blender 2.80. It looks like a tiny numerical difference, but it was like a huge step for Blender itself, and one of them was going to Blender 3. We are a little bit, we hold back a little bit on using all those new features. Also because Blender is bundled with different Linux versions, distributions. that each have their own version of Python. And so the features that we use are typically running behind the version of Python that we're actually using.
Thank you. So I just wanted to ask about, so you described how the interaction in Blender with Python can be, but I was curious about the API that Blender offer to Python outside. So if you can use Blender somehow to construct this virtual world and so get the data outside.
You can in a few different ways. You can just run blender -- Python expert and then a Python string that gets run. And depending on where you put that on the command line, you run it before or after the file gets loaded and that kind of stuff. You can also point it to a Python file that it needs to run. You can add a -- background to make it run in the background, then it doesn't even need a graphical environment. But also you can pip install bpy, the Blender Python interface. And that will download pretty much all of Blender for you, but then as a binary Python module. And so from a standalone Python script, you can just do import bpy and do the same kind of stuff that we saw here running inside of Blender itself. Of course, you don't see it because you don't have the graphical environment for it, but you can run it. Also, you can run like a network connection to an outside process and then feed it like that. Given an example of at Ubisoft Animation Studio, they use camera, like a virtual camera, that is basically a display that is motion tracked with a mocap system. And then you can feed the coordinates of the camera from the mocap system through a network connection into Blender and position the virtual camera exactly in virtual space where the real camera is in real space and project that view of the virtual camera on the monitor, and you have your virtual camera. Another example of this kind of interaction.
Thank you for your presentation. Do you have another animation that you made yourself that you can show us?
Do I have? No, because I'm not an animator.
All right.
Like I have really crappy stuff, maybe somewhere on a YouTube channel, maybe somewhere, but
That'd be awesome.
find it.
Thank you.
I can show later.
Anybody else? A question?
There.
Oh, there in the back. Move. There you go.
Hey, do you verify the extensions that get uploaded before they get used and also when they get updated?
Good question. Well, it is new. So do you? No, not yet. Will you? Up to a point. And that is also something that we're still looking into, like how to do that efficiently, because there's now an approval queue. So you can't just push something on there and then have it like visible for everybody. But also there's a level of trust that like you need and a level of responsibility for yourself to see these add-ons, just like you have on PyPy. Like anybody can go on PyPy, create an account, and start uploading packages. But yeah, there is some looking into things, but how to divide that among people, I think some volunteers will be very welcome.
Thank you. And for the last question, Anne-Marie. Yeah, here.
Yeah, thanks. You say that the rendering is almost near real time. That's quite amazing.
Well, that rendering with that render engine, with those people behind it to make it real time in that situation, yes. I do want to, just as an illustration of speed and how things can differ. The last commit of Ton Roosendaal, the founder of Blender, the last commit he made was, I think, in 2017, otherwise 18. And that was the removal of the Blender internal render engine. That was the one that used to be the render engine until Cycles came along, which is a path tracing engine, if I'm not mistaken. But that's like physically correct, whereas the Blender internal engine was doing more like OpenGL style rendering. Back then, Cycles was super slow, and Blender internal was like the fast, efficient thing. You had to tweak it a little bit to make it look good, but it was super fast. Now, a friend of mine recently made a comparison between Blender internal from that version of Blender and Cycles now, limited it to like 8 threads, I think, because that was the maximum that Blender internal could do. Limited a bunch of other things, other speed-ups on cycles to make the comparison there. And then still cycles beat the old Blender internal. So it's been optimized so much by now that like even the fast thing is slow in comparison.
Well, having said that, I would like to give a big hand to Sybren for this interesting talk.